Alright, this video is to help you understand matrix multiplication. It's a little bit different than adding and subtracting, just the way that we approach the problem. I'm going to go kind of quick, but again, feel free to pause and rewind the video as needed to watch any examples more than once. I'll also pause the video here and there to kind of let you attempt the problems and then fill in the answers as we go. The first thing you want to realize about matrix multiplication is that in order to actually multiply two matrices, the columns from the first matrix need to be equal to the rows from the second. So you'll notice that down here at the bottom, matrix A is a 2 by 3, matrix B is a 3 by 4. Because those 3's are equivalent, we can multiply these two matrices. We will result in a 2 by 4. The rows from the first and the columns from the second will give you your resulting dimensions for your new matrix. The reason that this happens is you'll notice up here at the top I've got a problem worked out. We're going to take the row from column 1 and multiply it by the column from matrix E2 here. So I'm going to take the 1 and the 2, the first two elements, I'm going to multiply them and add them up to now I kind of move to the right and move down. We walk along the row and down the column at the same time. 2 times 5 in the middle and negative 3 times negative 1 on the right there. Then notice you add them all up, which is why, again, this 2 by 3 matrix times this 3 by 1 is going to result in a 2 by 1 answer. I only have two rows and one column to multiply. I'm only going to get a row 1 and row 2 by column 1 set of answers. Again, you do the same thing for row 2, column 1, and you'll notice it's lined up here, and we end up with that negative 3 when we're done. Let's do that in this matrix here. So notice again, we've got a 3 by 2, and we've got a 2 by 2. So we're going to end up with a 3 by 2 because those middle numbers lined up, right? We're going to get 3 rows and 2 columns for an answer. So I'm going to make a 3. I'm going to leave a lot of room because I want 2 columns, right? But I'm going to have a 3 by 2 answer. Go ahead and try walking through the rows and the columns. I'm going to pause the video now, and I'll restart it up again when we've got most of it filled in. Alright, well, we've got most of it filled in down here at the bottom. Again, you'll notice that I took the 3 rows, so 2 and 3, 1 and negative 4, 6 and 0. And again, I made them into both columns here, so 2 and 3, 1 and negative 4, 6 and 0. In the first column, though, we're only using our first column numbers. So our negative 1, negative 2 is going to fill in all of that first column paired up correctly. Again, 2 times negative 1, 3 times negative 2, giving us row 1, column 1 of our answers. So again, I've got row 1, column 1, and in fact all of column 1 filled in. The one I didn't finish was technically row 2, column 1. And notice since all these things operate separately, you can kind of do it that way. Row 2 times column 2, actually, 1 times 3 right here, plus our negative 4 times 4. So again, positive 3 plus a negative 16 is going to be a negative 13 for an answer. You'll notice down here we've got a 2 by 2 times a 3 by 2, which immediately tells me, again, my columns don't equal my rows. This one's not even possible. You would have what's called a dimension mismatch if you tried to attempt that one. So just note to self, again, you need those dimensions to line up so that you can walk the rows and the columns together and make that line up. Let's go to our next page here, next slide, and let's see what we've got going on. So now, a good example of, again, the fact that order matters for these matrices. Notice that A and B are both 2 by 2's, so it really wouldn't matter what order we multiply. 2's are going to line up no matter what. However, if we multiply those out and get our answers, you'll notice that A times B and B times A do not come out the same. The row by column idea means that we're technically using different numbers. Even for matrix A alone, I'm using the 2 and 3 here, whereas now matrix A is over here, right? I'm using its column rather than its row. So I'm lining up the numbers differently. So realize that matrix multiplication is not commutative. So in that same way, realize we can use our calculator. It is occasionally commutative. Notice down here at the bottom, I've got what are called identity matrices. One with a bunch of zeros around them, and multiplying those out. Now this is a great opportunity to use our calculator. So what I'm going to do is go to my calculator and I'm going to enter in these two matrices, and then I'm going to show you how to sort of multiply them out via your calculator. So if you open up your calculator, and we're going to go to Matrix on here. I'm going to go over to Edit, and I want to enter in, oops, let me get my matrix, all right, calculator back on the screen there. A needs to be a 3 by 3 matrix. So you can enter in the elements just in order, -3, -4. Go ahead and pause the video now if you grab your calculator and do the same thing. I'm going to enter in matrix A, then make sure you go back to second matrix again. You can enter in matrix B, make sure you put the dimensions in first. Okay, notice I've got matrix B on here now. Again, I entered my dimensions as a 1 by 3, then I've got -2, 1, and 4 entered in, and we're all set there. So now I can go back to my main screen. And notice I want to multiply matrix B by my identity matrix. So actually I'm going to head back to my calculator. I'm going to go back to my main screen. And what I want to do is grab, oops, right there, quit. I want to grab matrix B, and I'm going to multiply it by matrix I. Now I'm not going to use the letter I in my calculator, but I'm just going to put in another matrix very quickly here. I'm actually going to use matrix D down here, number 4. And I'm going to put in a 3 by 3 matrix. 1, with some zeros, and then a 1, and then do the same thing, probably faster if I just arrow my way down, put in that last 1 down below. Alright, now that we've got that identity matrix entered in, again I can go to second matrix. I can grab that matrix name, matrix B, remember we were taking. Oops, clear that out of there. I forgot, I got to go back to my main screen first. So I'm going to go second, quit, matrix B, which I already had entered in there. Sorry for the fumbling here. And now I want to multiply that by matrix D, number 4 there. And you'll notice I actually got back -2, 1, 4. It's actually exactly what matrix B was before. Let's take a look at that. We're taking row 1 times column 1. And notice the only number that's going to stick around, -2 times 1, is -2. 1 times 0 and 4 times 0 added on to that is just going to disappear. Well, now same thing in column 2. -2 times 0 is 0. 1 times 1 is 1. And 0 plus 1 plus 0, essentially, right? 4 times 0, third number, disappears. In the last column, same thing happens. -2 times 0, 1 times 0, added together is 0, added on to, again, 4 times 1 is 4. Whenever you multiply the identity matrix, if it's possible, right, 3 by 3 times 3 by 3, by another matrix, all the correct parts stick around. So, and the commutativity, as I mentioned already, actually works with the identity matrix. If you follow the numbers, you'll notice that those numbers will stick around. That's why we call it the identity matrix. It preserves the identity of anything you multiply it by. A couple quick examples where we can use matrices in the real world. Notice here we've got the inventory essentially for 3 different softball teams. So we've got the varsity, the JV, and the freshman teams down here. And again, the number of softballs, bats, and jerseys that they have. We organize those purchases into a nice 3 by 3 matrix. Now I can multiply them by the costs. Now I got to be careful though, because if I multiply them this way, 3 by 3 times a 1 by 3 is not going to work. So if I accidentally multiplied my costs this way, I'm not going to be able to enter those in. So what I'm going to do is switch that up. I'm going to use what's called the transpose. If I entered this into my calculator by accident, I don't need to retype the whole thing. I can actually use what's called C transpose. Right? C to the T power essentially is what it looks like on our calculator. And it'll switch my row for my column. And let's just do that once real quick. Notice we've got this answer right here. If I go to matrix and math, notice the second option is that T, and watch what happens. That row just became a column. That 1 by 3 became a 3 by 1, and everything kind of switched around. Because if I do that, now I can take these and multiply them. Notice that my varsity squad, softballs, bats, and jerseys, will now be multiplied by the prices of the softballs, bats, and jerseys. And we'll end up with a good answer when we're done. Go ahead and practice that one. I'll pause the video now. Go ahead and fill in the numbers. It's a good chance to kind of practice doing that multiplication, and then we'll move on to one more example. All right, I'm back with you. Again, if you took 10 times 5 is 50, 5 times your 85 is going to be 425, and 20 times 20 would be 400. Add all three of those numbers up, you're going to get your 875 right here. And again, do the same thing with row 2, column 1, row 3, column 1. You get three numbers. And notice this would have been the total cost. Again, notice this was row 1, so of just the varsity. So we've got all three of our teams still separated out, but again, we have our total costs for each team. So the matrices work in kind of a unique but interesting way to help us organize information. Again, we can do that again on a little different example. We've got a manufacturer with CD players. And a little bit of an old example, but that's okay. But we've got our matrix organized here. Again, model I, so all of the rows, right? All the rows are referring to the number of units that are shipped at each warehouse, J, right? J being the column. So we've got two different warehouses. We can call them A and B or whatever we want to call them there. But again, we've got the inventory for each warehouse represented. We also have the price, right, per unit. So the different types of models, right? Model, the first model, second model, third model, first model, second model, third model. And notice again, we're in a column, we're in a row. So that's why they said, let's take matrix B times matrix A, because I've got models 1, 2, and 3 here, times models 1, 2, and 3 there. And we can make that happen. If we multiply those out, we'll get ourselves a nice answer over here at the right. And again, what did those represent? Well, we represented the two different warehouses again. So we've got the warehouses, right, represented, column warehouse 1 and warehouse 2. Here's the total inventory, right, the total cost of the inventory in warehouses 1 and 2. So the total value of the units contained in each warehouse. Hope that helps you with matrices. If you have any questions, make sure you talk to your teacher, and have a great day.